Finding the inverse of a matrix can be a complicated process. I want to show you how we can use row operations to find the inverse of a 2 by 2 matrix. In this case, the matrix is first row is 3, 1, the second row is 2, 4. And the idea is, if I'll write it like this. If I multiply 3, 1, 2, 4 by whatever the inverse is, I should get the identity, because that's what inverse means. Now, one way to do this, it takes kind of like a lot of writing, but I wanted to show you to give you the idea. If I do stuff to both sides of this equation, namely multiply both sides by matrices, in such a way that eventually the thing on the left becomes the identity matrix, kind of like you do when you say like 5 times 5 inverse equals 1. And then I would say, well, I wish this 5 on the left was a 1, so I'll multiply by 1/5. Whoop, that should be a minus there. Multiply the right side by 1/5 also. This turns into 1 times 5 inverse. Or just the inverse of 5. Now this seems really unnecessary and circular because it seems like I have to know the inverse in order to calculate the inverse. So maybe that's not the best analogy. Anyway, through a series of multiplications, it's going to take 5 of them, but I'm not going to do all 5 because I'm going to show you the shortcut after that. But we wish this thing was, we wish that it was 1, 0, 0, 1. And if I multiply both sides of this equation by 1/3, 0, 0, 1, that would cause this 3 to turn into a 1, which would be like making progress. However, it would also turn this 1 into a 1/3, which maybe I don't want to deal with fractions. You could, if you don't mind the fractions. But I'm going to do as my first step, I'm going to multiply both sides by 0, 1, 1, 0. What that does is it brings the 2, 4 to the top. And I like the 2, 4 because it's easier to turn that 2 into a 1 without dealing with fractions. Now, when you do on the right side, those rows get swapped also. Now I'm ready to make this 2 into a 1. That I can do by doing one of these scaling matrices. But you have to do it to the other side also. So now this becomes 1, 2, 3, 1. On the right-hand side, it becomes 0, 1/2, 1, 0. A matrix like this multiplies whatever row has the number that's not 1, it gets multiplied. Every element in that row gets multiplied by that number. Now, the order is, next I'm going to take care of this 3. Making that a 0 is pretty easy if I do this type of row operation, or this type of multiplication. Something like this will replace the second row with whatever the second row was plus -3 times the first row. Notice how this number is just the opposite of this number. And that's why we wanted to have a 1 up here, because I could really easily, this row operation basically does -3 times 1 plus 3 is 0, -3 times 2 is -6, plus 1 is -5. I have to do this to the other side also. -3 times 0 is 0, plus 1 is 1. -3 times 1/2 is -3/2 plus 0. Now that I've got this row, this column, sorry, how I want it to be. I now work on the second column. You start with where's the 1 going to go, and it's going to go there in the bottom corner. So the row operation I'm going to do is 1, 0, 0, negative 1/5. That's going to turn this negative 5 into a 1. But I have to do it on the left side also. So the second row of the left side is going to get multiplied by negative 1/5. Okay, and finally, I really want that to be a 0. I can accomplish that by doing 1, 0, 1, negative 2. That replaces the first row with negative 2 times the second row plus the first row. I need to do it on the other side also. And I end up with 1, 0, 0, 1, A inverse. That was my goal. Over here, the second row stays the same. The first row becomes negative 2 times the second row plus the first row for each element. So negative 2 times 1/5 is 2/5, plus 0 is 2/5. Negative 2 times 3/10 is negative 6/10. Negative 6/10 plus 1/2 is negative 6/10 plus 5/10 is negative 1/10. And then finally, I don't need this inverse. I don't need this identity anymore. So it took 4 steps. Actually, it took 5 steps because I did a row swap. I didn't have to, but I wanted to avoid the fractions. So that looks pretty hard, but I'm going to show you that a shortcut for this that has the same sort of idea, but it's much, much easier, is to instead write the original matrix, and instead of doing the whole equal sign, just put a line here and put what was on the right-hand side of the equal sign over here. Now, instead of thinking of matrix multiplication, I'm going to do row operations. Remember the 3 row operations? One of them is that we are permitted to swap 2 rows, as if you do it to both sides, or in this case, this is kind of like both sides are in the same matrix. You're also allowed to multiply. You're allowed to multiply some row by something and add it to another row, and that goes into the other row. And we're allowed to multiply a row by some number. Well, using those 3 rules, I can model exactly what just happened. First thing I'm going to do is I'm going to swap row 1 and row 2. It may not be clear why I'm doing that, but it'll become more clear now because I'm going to turn that 2 into a 1 by doing 1/2. Row 1 goes to row 1. Yes, I could have started by doing 1/3 of row 1, but since I noticed this 4 here was a multiple of 2, I felt it would be easier. Try to avoid fractions when you're doing these by hand. Now to get that 3 to be 0, I do negative 3 row 1 plus row 2 goes into row 2. And we do that. The whole first row stays the same on both sides. But the second row, this becomes a 0. Negative 3 times 2 is negative 6 plus 1 is negative 5. Negative 3 times 0 is 0 plus 1 is 1. Negative 3 times 1 is negative 3 plus 0 is negative 3. The next row operation is to turn this thing into a 1. I do that by doing negative 1/5 row 2 becomes row 2. So row 1, every time you do a row operation, only one row changes. This becomes negative 1/5, and negative 1/5 times negative 3 is 3/5. And finally, to make that into a 0, I do negative 2 row 2 plus row 1 goes into row 1. It's always the thing that you're adding to that becomes the new row. So the second row doesn't change at all. But the first row, you do negative 0, negative 2 times 0 plus 1 is still 1. Negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times 1/5 is negative 2/5 plus 0 is 2/5. And negative 2 times 3/5 is negative 6/5 plus 1 is negative 6/5 plus 5/5 is negative 1/5. And this here is the solution. So the thing that turned the number, the matrix, into the identity, turned the identity into the inverse. It's kind of like if I did this, the number 5 and the number 1. The thing I have to do to the thing I'm trying to find the inverse of to turn it into the identity, if I do that same thing to the identity, it turns into the inverse. That's the idea. Anyway, that's how you could find the inverse by hand using row operations.